Hi, my name is Christopher Tan, and I'm a fourth year biomedical undergraduate and also the team leader of NeoFusion. We are developing a novel syringe pump aimed at addressing neonatal mortality in low resource settings. So, to first introduce our problem, we looked into literature on global health and what are the most prevalent issues facing our society today. And what we found is over 2.3 million newborns lose their life within the first 28 days of life each year. 98% of these deaths are focused in lower resource areas, and many of them preventable. And so we want to understand how our healthcare systems are failing and what we can do to fill it in. What we found is a variety of literature from the World Health Organization and UNICEF analyzing how previous devices have been ineffective in these areas, with only 10 to 20% of them remaining functional long term due to a variety of factors such as lack of repair infrastructure, lack of consideration for the environment that these devices are going to be used in regarding humidity or temperature, and etc. And also the lack of human factor considerations on training and ease of use by different operators and across different cultures. And so, with all these different factors in mind, we wanted to choose a medical innovation that we thought would have a very high yield and make an impact on neonatal mortality. And talking with our collaborators at the UCI NICU, including Dr. Uy, the medical director of the UCI NICU, we chose the syringe pump. It is a device that accurately infuses any medication within a syringe over a gradual amount of time. In these areas where they have nurse to patient ratios of instead of 1 to 2 up to 1 to 50, it is essential to have these automated processes where you can deliver medication slowly and gradually, and especially for newborns and small neonates, they require such small and precise volumes that can't be achieved by hand that these devices are essential for. So with that in mind, we put all the priorities of these low resource areas first in our device design, thus choosing to make it a fully mechanical system where it can be used anywhere off grid, even without reliable access to electricity, which was a major barrier that we saw appear in our literature searches. Alongside that, we're making it a robust device, making it repairable, and these are all the research questions that we're also asking in our proposal here. We are doing testing on the robustness and life cycles of our device. We're also using and following international standards on testing the accuracy and precision of our device and making sure that it can reach the range of infusion rates as specified by the literature. Alongside that, we've been working very closely with our collaborators from the World Health Organization, our UCI Medical Center, and our business mentors in order to make sure that we're targeting all different dimensions of our product, reaching out and getting in touch with actual clinicians and nurses on the ground and getting them to get their input on how our design should finally manifest. And so with this project, we've been getting preliminary results showing our device is precise and accurate, actually exceeding the benchmarks for our standards testing. And we are continuing to do testing and designing new tests on the robustness of our device, life cycles, and other human factors, where we're going to be bringing in participants to use our device, see if it is intuitive or not, or make ergonomic changes based on our results. But yes, thank you so much for your time and consideration.